Yo, what's up, guys? So today I'm gonna tell you something really important about the calculus part. There, the unit one really important topics. There are limit laws, left and right hand side limits, limit at infinity, and the function's continuity, and intermediate value theorem, which is also called IVT. So I'm gonna use four questions to illustrate these three concepts. So for the first one, when it's actually a limit loss problem. So we firstly have to direct substitute it to verify whether it can be directly substituted out, or we have to do something more like factor or something else. So we directly substitute, then we got 0 plus 0 over 0 plus 0. We got 0 over 0. So which is not valid, so we have to find another way to solve it. So what I'm trying to do, so if I would factor x squared out, which will be denominator will be x squared times 3x cubed plus 12 over denominator we pull out an x squared, which is x squared times 5x squared plus 6. So x squared eventually canceled out, and then that's what we left. All right. So this time we can directly substitute it because it doesn't give us the 0 over 0 again. So we plug 0 to the functions, we got this one is 0, this one's 0 also. So we got 12 over 6, which is 2. So for this question, we choose C. Alright, next one. So this is a limit as x approaches to the left hand side. So what we have to do is we have to figure out whether it approaches to the negative infinity or positive infinity. The This one is pretty tricky because you have to. It's a little bit kind of hard to find whether it goes to positive infinity or negative infinity. But eventually we can easily solve that by this trick. So we basically see its limit as x approaches to the straight from the left hand side, which means x should always go to the x should be 2.999 or something. It always goes infinity, but it never like get equals to 3. So which means denominator x minus 3, we should have a negative value, which is 0 from the left hand side. I mean approaches to 0 from the left hand side. And for the denominator, so it basically goes to the 3, which means denominator should be a negative value. So just a negative value over a negative value because it's approaching 0 from this side. So whatever, so it just approaches to 0, but never equals to 0. So which means it's always infinitely close to 0, but not touch it or equal it. So which means this one get extremely like smaller, which means the total fraction will be extremely higher. And we have to determine the symbol in front of it. It's a negative and it's also negative, so the solution is positive infinity. So we choose B. All right, next one. So next one is an intermediate value theorem. So basically means if a function is continuous in a closed interval, then we got if we just said that if r is in an interval. I mean, for this question, I will give example from this question. So if r is in an interval from if r it's an interval, which this means belong to, then there will be f of 3 um, f of 3 small less or equals to f of r less or equals to f of 5. Alright, so we just plug in number. 9 is less or equals to f of r, or f of x, less than, and f of x is equals or less than 22. So let's check the answer respectively. First one, f of x equals to 11 has at least one solution in the open interval. Yeah, that's right, because f of x equals to 11 is in this big interval for the y value, so this one is valid. And next we solve the next one, f of 4 equals to 13. So actually we have no idea about a specific value for the f of 4, so this one is not valid. Next one, f of x has at least one zero in open interval at 3,5. So this one we have to determine 0, which means, so in which situation can we determine there must be a 0? So it's still intermediate value theorem, but we need to have a number it's smaller than 0, y value one y value is smaller than 0, which is from here, and another one should be greater than 0. So basically the function goes continuously, so whatever it goes, it has to go through the x-axis, which means there must be a 0. But for this one, f of 3 and f of 5, they're both positive. All right, they're always positive, and so they're not any. I mean, there's probably a possible there is a 0, but you cannot pretty sure. So this one is at least 1 0, which means this one is incorrect. So we cancel it out. Alright, the next one, f attains a maximum value on the open interval 3,5. So this one is more unreasonable because you have no idea about the maximum value. The function didn't give you any information about the maximum value or the vertex or something. So this one is wrong. So the answer is A. Our next one. So this one is actually a average change of rate. I mean, not average change of rate. It's instantaneous rate of change. It's instantaneous rate of change for the f of x equals to 3x squared plus 4x. So I'm gonna do it as usual. So lim h approaches 0, f of x plus h, which equals to 3x plus h squared plus 4x plus 4h, and minus original function, which is 3x squared plus 4 over h. And then we still go on for the steps. 3x squared plus 6xh plus h squared plus 4x plus 4h minus 3x squared plus 4, minus 4 over h. So we cancel out this same term, which is negative 3x squared, positive 3x squared, negative 4, and oh shoot, I'm sorry, I forgot to minus 4 in this fund. It's actually 4x. It's 4x. It's 4x. So positive 4x and negative 4x goes cancel out, and then when we left, it's 6xh plus x squared h squared plus 4h as limit as h approaches 0. So we cancel this out. Alright, cancel h out. So which left us lim as h approaches 0, 6x plus h plus 4. Oh wait, hold on 1 second. So plus 4, yeah, plus 4. And there's no h for denominator because it goes cancelled during the simplification. So as edge plus 0, what we left is 6x plus 4. So this one choose B. Alright, so today is still an intro course for the Calculus BC Unit 1, which is basically about the three really important topics: limits law, left and right hand side limits, and limits as infinity, and also the continuity and the intermediate value theorem. So please leave the comments and let me know what points are confused or still trying to figure out but you can't. I will try my best to help you. See you guys tomorrow.